Welcome students. Today we will study factorizing of a polynomial. Factorizing of a polynomial, when we say, it means any degree polynomial. It may be degree 1, degree 2, degree 3, degree 4. It is class 9 topic, factorizing a polynomial. We learn different type of factorization, but it is difficult to think how to go about it. So I have set a system where we learn stepwise procedure of factorizing the polynomial. Whenever you get a question of factorizing a polynomial, I will explain one to one step how we will try the first step. The most important step, as I have written, very important, is step number 1, part A, take common throughout if any. This is the simplest factorization of taking a common factor throughout all the terms of the polynomial, which we generally miss. So it should be tried, and it should be tried only in the first position, as I have written on the top, take common throughout if any. If there is nothing common, we can go to next step. Specifically, first step B part, if number of terms are 4, we try common in pairs. It is something like the method of splitting middle term. When we split the middle term of a degree 2 polynomial having 3 terms, we split the middle term and we make it 4 terms. I make it 4 terms, and then we take common in pairs. So same, if the polynomial is originally of 4 terms, we think of taking common in pairs, and it works. Sometime when nothing works, it works. The second step is, if the degrees of polynomial 2, will go in the order. We'll go for degree 2, degree 3 and degree 4. When the degree of the polynomial is 2 and the number of terms are 2 only, with a negative in between, the easiest polynomial factor identity which is applicable is x square minus y square is equal to x plus y into x minus y. X plus y into x minus y. I hope you are able to see this, the screen, and you can copy down the steps in your copy, or I can even share the click of this in the group. So when the degree is 2 and the number of terms are 2 only with a negative in between, we see whether we try. The term is we try. We think of applying method identity 1, x square minus y square equal to x plus y, x minus y. This is the easiest possible step. The easiest step, simplest identity, is degree 2 polynomial. If the degree is 2, but instead of 2 terms, there are 3 terms, we think of identity number 1, which says x square plus y square plus 2xy is equal to x plus y the whole square, and x square plus y square minus 2xy, then it is x minus y the whole square. But if you see on the right extreme, I have written a word 60% success. What is the meaning of 60% successful? This method is only 60% successful because in 40% questions, the identity is not applicable, but the method of splitting middle term is applicable. So in step 3, part B, we try the method of splitting middle term. Here in front of method of splitting middle term, I have written 100%. So the point I would like to clear here is the identity method is applicable only in maximum 60% questions. This method is applicable only in 60% questions, whereas the method of splitting middle term help you to solve all 100% identities. It helps you to solve all 100% identities. Every question can be solved with the help of splitting middle term method, whereas with the identities, only 60% questions can be solved. So I will advise personally to not to use these 2 identities unless or until you are forced to you are told forcibly that you use identity to factorize the polynomial. Then you should use only splitting middle term method, as it will solve you all 100% questions of degree 2 and number of terms 3 polynomial. method of splitting middle term is successful. But if we go to degree 3 and then initially for 2 terms and then we'll talk of 4 terms, if degree is 3 and number of terms are 2 only, then most probably both the terms will be perfect cubes. Both the terms will be perfect cubes. Either it will be x cube plus y cube form or it will be x cube minus y cube form. Either it is x cube plus y cube or it is x cube minus y cube. So when it is x cube plus y cube, the identity applicable is x cube plus y cube equal to x plus y into x square plus y square minus xy, where x is the number in the first bracket and y is the number in the second bracket. When we go for a negative sign, it is x cube minus y cube is equal to x minus y is into x square plus y square plus xy. Here I would like to again tell you a trick that when we try to learn these identities, the first bracket sign matches with the sign of the left hand side and the last term of this second bracket goes against this sign. If it is positive, the last term will be negative. The first 2 terms remain same in both the brackets, in both the identities it is same, whereas the third term is also same, but the sign matters. In first identity it is opposite to the plus, it is negative. In the second, when it is negative, the last term will be positive. This is the way to remember the identities for the purpose of examination. Then we talk of degree 3 and number of terms are 4. I find there are 3 terms, 3 identities which are of degree 3 and number of terms are 4. There is a separation between these two. First 2 are of the similar type. It contains 2 perfect cubes. First and last term are perfect cubes and the others are degree 2 and 3 combination. So first and second, the only difference is in first identity all the terms are positive. X cube plus 3x square y plus 3xy cube square plus y cube, then the answer is x plus y whole cube. Whereas if it is x cube minus 3x square y plus 3xy square minus y cube, means half the signs are positive and half the signs are negative, the answer is x minus y the whole cube. I would like to mention that identity 3 is little different from the first 2. The only difference is in the first 2 identities there are 2 terms which are perfect square, but in identity number 3 there are 3 terms which are perfect cube, first cube, second cube, third cube. In first 2 identities there were only 2 cube terms, first term and last term. First term and last term. There was no perfect cube in otherwise. But in this identity there are 3 perfect cubes and another term negative 3xyz. The answer for that is x plus y plus z plus x square plus y square plus z square minus xy minus yz minus zx. So to go for the lower part of the method, because this method is a bit long, it consists of 8 steps. As you can see on the board, there are after degree 3 there are still more steps, and to know about them we have to note down further step number 5, step number 6, 7 and 8. There are 3 more steps. I believe it is visible to you. Step number 6 says if the degree of the polynomial is 4 and the number of terms are 2, as I said, degree 2, degree 3, degree 4, and if in degree 4 there is only unique identity a4 minus b4, the first term will be raised to power 4 of some number and second number will also be raised to power 4 of some number. So a4 minus b4 is the identity, and the answer for that is a square plus b square, first factor, into a plus b, second factor, into a minus b, the third factor. So you have to learn the identities, of course, that is the basic thing. You have to remember all the identities, and degree 4, step number 6. Step number 7 is another exceptional step when all these methods may fail and the degree of the polynomial is 3 and no number of terms are 4. If step 3, this one fails, not step 3, I believe step 5, degree 3 and number of terms 4. Step number 5 doesn't apply. Then we think of hit and trial method. You must be aware of hit and trial method. We do the factorization of the constant term and the factors of the constant term we try one by one in the polynomial. We come to know the zero of the polynomial, and as we come to know the zero of the polynomial, we come to know the factor of a polynomial. So we find one or two factors as per the question. If it is degree 3 polynomial, we'll find one factor and divide the polynomial with degree 1 factor. The quotient will be degree 2, and it will be a degree 2 and having 3 terms, which can be further factorized by splitting middle term method. So that will complete your factorization in case the step number 5, all 3 identities fail to help you out. And this is exceptionally in one question. So I have mentioned it at separately step number 7, and step number 8 is also a unique identity of degree 2 and having number of terms 6. You must be aware of that identity. If the number of terms are 6 and degree is 2, we go for identity a square plus b square plus c square plus 2ab plus 2bc plus 2ca equal to a plus b plus c whole square. So this is with my experience, I have made this stepwise procedure, which you will not find in your books generally. I saw it. I am doing it for last 35 years, but I saw it in 2-3 years ago. I saw in some book it was written somewhat in the similar manner. So you will not find it in any other book. Please try and apply this. But the key to the success is you must know all identities by heart first, and you should recognize which identities of degree 2, which are the identities of degree 2 with 1 term, degree 2 identities with 3 terms, degree 3 identities of 2 terms, degree 3 identities of 4 terms, and degree 4 identity, the unique identity, and degree 2 identity having 6 terms. You should remember them category wise so that you can switch on. Once you look at this method, it will appear, oh, it is an 8-step method. For one small question, we'll apply 8 steps. No. As soon as you look at the question, you immediately jump on the method applicable. If you come across a degree 3 question, so you will not bother, you will only bother for step 1, and after one step, you will straight away come to degree 3. If it is of number 2, you will come to step number 4. If it is having 4 terms, you will straight away jump to step number 5. It is not that you will try 1, 2, 3, 4, 5, 6, all the steps, but you have to segregate immediately and jump onto that type. If there is a question of degree 4, there is after first step is most important. You have to apply